Hello everybody out there in YouTube land. Good times for all here. Zachary Zabala if you prefer. This is going to be the first of probably a few videos I'm going to be redoing. I got the new camera and you'll be able to see things a little bit better, what I'm trying to show you. If there's any certain videos that you'd like to see redone, please let me know. This one is going to be wirelessly observing current through a fluorescent bulb and how current acts coming off of the source. Now this is a positive current that we're going to be using coming from the Van de Graaff generator. Now the way it comes off of the sphere or the globe here, they call it, it'll be coming off at a 90-degree angle from the surface. So from anywhere on the surface, it will start off coming straight out. In any direction, it's going to come straight up, you know. If it were a flat surface, it'd be going straight up from it. And then when you got near the edges or the fringe, as they call it, it would start acting sporadically. Now the sphere will fall off at 1 over r squared, the inverse square law, and that's why I'm going to get it real close, because we're not dealing with, for one, it's really no current. The current that's only being created is by me turning this wheel. That's where the currents come from. So when I stop turning the wheel, this pretty much stops creating any type of a current. And then all you have left is static electricity. Now electricity can be dispersed in 3 different ways. You have your light, you have your heat, and you have your sound. Now I'm sure there is heat happening within here when it lights up, but we're not going to be able to really measure that at all. It's so minute. What we can do though, we can see the light and we can hear the sound that it makes. Now I'm going to bring the camera a little bit closer so you can hear the sound when I start cranking this thing. Actually, we'll do that one first with the light on, so you can just hear it, and then when I turn the light off, I'll set the camera back down so you can see it, what's happening. And I've also discovered something new, which is really interesting, that really sparked me to do this whole redo the video thing. So here we go. I'm going to bring you a little bit closer here. Now listen to this. You guys hear that? The Van de Graaff's over here. Oh, I don't want to get that too close to it. I don't really want to get my phone too close to that either, I don't think. But did you hear that? Now it's lighting up a little bit in there, but that noise is energy dispersing. There's also light going on. You can't really see because I have the light on. And then the heat. The gas is lighting up, is putting off a heat. So the energy I'm creating is being dispersed very rapidly to where it's not really doing much. My negative is just gaining a charge back here, but really most of the electricity is going through the... And as you'll see, when I turn it this way, you won't hear anything now. See that you hear the Van de Graaff popping. There might be a dog hair or something on it. That's because there's no current going through from this electrode to this electrode and traveling through our pipe here, our cylinder. There's no electrons, theoretical object. I just like to call it a current, an electric current, which I'm getting, this thing doesn't scare me at all anymore. I can charge it up pretty good. Well, I haven't been super blasted yet, but it doesn't See all that noise and stuff that's happening first? That's my hairs reacting something, I don't know what's going on, but that discharges it a lot. I can't get a really big zap. I've been trying it and trying it. Anyway, that's neither here nor there. We're going to turn the light off. And we're going to light this thing up. And as you can see, it's just barely glowing a little bit. And as I put my hand here, it should start glowing a little bit more when I touch it. You see that? Now here's the really interesting thing that I learned. I'll take the negative electrode, bring it through here, and when I get this thing to zap the electrode, it really lights up that tube, like it's almost being lit. And my electrode is actually, it's not really near the tube. My discharge. Here, let me put it somewhere you can see it going off. See, it's up here. Not making a huge arc. I'll try to pull it away a little bit more and see if I can't get it to zap it. It really doesn't want to. When I get it about 1.5 inches away, but as you can see, it really will light it up. And the further away I get it, the more charge I get it built up, the brighter the light is. So what that is telling me, let me get the light real quick. So what that is telling me here, folks, is that, see, this is all I was doing. I had this over here. You can kind of still see it getting lit up. But what that's telling me is, even though, I'm going to pull it a little bit further back and pull this a little bit further back. But even though most of the charge you would think is coming over here to the negative discharge globe sphere, you know, my wand. But that's not the case. From what I observe here, what I'm seeing is, when this discharges here, it doesn't only discharge here, but all the electricity on it, maybe in this one area, all of this is going to this right here. But over here, and probably, you know, but if I had lights all around it, actually I'm thinking, maybe that's what I'll do. I'll set something up like that. But it is discharging in every direction. It is really, I mean, you saw it. Whenever this thing discharges on the, even, doesn't matter what side I put it on, you know, it's not like I'm doing it just on the opposite side. Oops, sorry about that. Dropped you there. But yeah, it's not, it doesn't matter where I put this wand. I wonder if I put the wand in between it. Haven't tried this yet. It does it, but not that bright. So, from wherever the source is coming from, on the surface, at a certain point, it is just right here where the charge is taking place, right here, between these two. Maybe it's grabbing it from, I have no clue how much it would be grabbing it from. That's a good question. But from over here, this side is also taking all of its charge all at once. Bam! Shooting it out in every direction, I bet. off the surface. And that's what I get from this. So I don't know what you would call that. Just something I want to share with you. So that's it. This is already longer than I wanted it to be, but I thought that was pretty neat. So this is Good Times for All, signing out. And as always, thanks for watching.